Hello and welcome to another session on Java programming. So in this session, we're going to take a look at the use of a TreeMap class in Java. We'll also be taking a closer look at the various interfaces that this specific class implements. We'll be looking at the following interfaces: map, sorted map, and navigable map. We'll also be looking at the various methods associated with the TreeMap class. If you're interested in downloading the code that we're using in this session, then please visit codespindle.com and under the category programming, select Java, and to the left hand side, you'll be finding this title TreeMap. If you click on the title, you'll be able to see the code that we're going to use in this session. So first, we'll be taking a look at the various methods available in all these interfaces and the hierarchy of inheritance among these interfaces. And then we'll be taking a demo on the TreeMap class. Let's go to the session straight away.
So what is that we are going to take a look at is on map, sorted map, navigable maps and tree maps. So I told you, you might have learned dictionaries in Python. What is the use of dictionary? You will store some key and value pairs. Key value pairs. So maps will be used in Java for storing key and values together. That is the concept. So we'll start off with the definition for a map. What is a map? Map is nothing but a data structure that maps keys to values. So you have a key and a value. The properties here, keys should always be unique. Registration number of students can be a key, right? Name is the value. So key should be unique, name can be duplicates. Students with two different registration numbers can have the same names. So maps are useful for storing data in a way that it makes it easy to retrieve and update values based on their keys. So you want to access a value from within the map. How is that you're going to access it? You're going to use the key to get the value because keys are unique. And I've given some examples here. For instance, I want to store data of countries and their capitals. So country name is the key, capital is the value. So you can store such key value pairs. Not only that, student registration number, say 12BC001 and then name, Satish. So like that, you can store the list of students with their registration numbers. So key value pairs are used for maps are used for storing key value pairs. So what is this map in Java is? It is an interface. We all know what is an interface, right? An interface will have only abstract methods. So when you have this map interface, it defines a lot of abstract methods. Put. What is the use of put is you'll insert a key and value pair into the map. And get is for getting the value based on a key. Say I want to get the name for this registration number 12PC001. How is that I'll perform that? I'll use this method get. Remove is for removing a key value pair using the key. So if I pass the object key, it will remove that key value pair from that list. Size is for returning the number of key value pairs in the map. So you have to understand map is what? An interface. It is at the highest level. So map is an interface and it has got some abstract methods. What other abstract methods map supports is empty. Just tells you whether the map has got any key value pairs or not. Clear is for removing all the key value pairs from the map. Contains key. What is the use of contains? It's a Boolean method. It is used for checking whether a key is present inside your map. So say contains key, I pass the key 12BC001. Then it will return true if the key is present inside your map. Contains value. So this is like Satish is the name of that student. So if I check contains value Satish, it will search the list of values and then it will return whether that true or false. Set. So this is another method called entry set. What is the use of entry set is it returns all the key value pairs as a set view. So you have say 10 key value pairs, all the key value pairs will be returned as a set view here. So that is the use of set method. So what is that we understand is map is an interface And what is the use of map? It's a data structure for supporting key value pairs. And as an interface, it supports all these abstract methods: put, get, remove, size, is empty, clear, contains key, contains value, entry set. There can be other methods also inside the map interface. We're just focusing on a few here. So map is an interface. Now we'll talk about sorted map. What is a sorted map? Sorted map is nothing but it's again another interface. So map is an interface. It's an interface map. And sorted map is another interface. This is also an interface. And the relationship between sorted map and this map is extends. We have seen an interface can extend another interface. What it means is it inherits all the abstract methods and it has got a few more abstract methods. Sorted map adds a few more abstract methods to the interface map. So what kind of methods that sorted map adds is it ensures that the key value pairs are sorted according to their keys. In a map, say you have some, you insert data like this 12 BCE 002 and then you give name as Satish, and 12 BCE 001 and then you give name as Ram, 12 BCE 004 and then you give name as Tom. Now when you retrieve the data, it will not be in the sorted order when you use a map. So what is the use of a sorted map is it has got few more methods that will sort your map according to the keys. So it will be sorted in the ascending order of the keys. So that is the importance of sorted map. So you have this interface map and interface sorted map. Sorted map extends interface map. So when you sort it, what will be the output here? It will be sorted according to the keys. So 12BC001 Ram will be coming first. 12BC002 Satish will be coming next. 12BC004 Tom will be coming next. Now it is sorted. So now you have some methods that will help us to retrieve the very first key. So we can retrieve the first key in the sorted list. We can retrieve the last key in the sorted list. So that is the use of a sorted map. Again, sorted map is an interface which has got certain methods. I'll show you some methods in the sorted map interface. This is first key. What it fetches? The first key according to the sorted order. The last key, again the last key according to the sorted order. And it has also got methods. Key set returns all the keys in the ascending order. So these are some additional methods that sorted map supports. Not only this, there are other methods too. Just to tell you what a sorted map is. So interface map on top, next comes sorted map, which inherits this interface map. Are you all clear with this? Maps. Key set is nothing but you just understand this to be returning all the keys in the ascending order. That's it. We'll see the demonstrations, then we'll understand. First, we'll look at the theory, then we'll implement all these methods. So, the next thing in the hierarchy, when you take a look at this, you have interface map. We know what these methods, what are the methods supported by interface map. We have seen sorted map, which extends map, and it helps us in sorting the entries. Next, we have this navigable map, which is again an interface. So navigable map extends sorted map. What is the use of navigable map is it has got some additional methods for navigating through your sorted map. That's it. So some more additional methods are supported by navigable map. So as navigable map is an interface which inherit sorted map and map. So it's going to inherit the methods of map, methods of sorted map plus additional methods here. What is the use of these additional methods? It's used for navigating through the map in either ascending or descending order. You can navigate through that sorted map. That is the use of navigable map interface. So we have some methods. I'm just giving a few methods from the navigable map. That is descending map returns a navigable map containing all of the key value pairs in the original map in the reverse order. So it just reverses the order and gives your key value pairs. Earlier it was in the ascending order. Now you can see the key value pairs in the descending order. Higher key, lower key. Say if I am searching for a key like 2, it will return the next higher key. If the next higher key is 3, it will return 3. Likewise, lower key, if I am searching for a key 3, if the next lower key is 2, it will return the entry corresponding to 2. So, there are certain methods with respect to navigable maps which were added for navigating through your sorted maps. So, you should never forget this, that is, map is inherited by sorted map is inherited by navigable maps. See, all these are interfaces. So, whatever you have seen is an interface. How will you use an interface? How will you use an interface? You will use a class and then you will implement that interface. Say, I have a navigable map. How will I use that interface? I have to implement navigable map here. So to use all these methods, we have this TreeMap class. TreeMap actually implements navigable map. So TreeMap is the concrete class with implementation for all our methods in the map, sorted map and navigable map. So if you want to use those methods of map, sorted map and navigable map, you should create an object of TreeMap and then invoke those methods. So tree maps, what are tree maps? It maintains key value pairs and it implements navigable map. So let's maybe take a look at this. What is this tree map? So here let's take a look at the declaration for tree map. So public class tree map implements navigable map. And what is this navigable map? Navigable map extends sorted map. It's an interface extending sorted map. What is sorted map? Sorted map is an interface extending map. So this is how it has been implemented. Now our focus is on TreeMap. What is TreeMap? TreeMap is a class which is implementing our navigable map. So there is some more theory on tree maps. Tree map stores your key value pairs as a self-balancing binary search tree. Have you studied self-balancing binary search trees in your data structure course? So it can be red, it is red black tree here. So you know other self-balancing binary search trees. So here, what is the use of self-balancing binary search trees? What is the advantage of using self-balancing binary search trees?
Search complexity will be the least always.
Search complexity will be the least. If you keep on adding, deleting nodes, the depth of the tree will always be constant, right? So it will self-balance and adjust. If you're not going to balance, the tree may get skewed and then it will lead to linear complexity. You understood? So tree map, what is the use of tree map? When we go in for tree map is you want to maintain all your keys in the form of a self-balancing binary search tree. So that is how it is implemented. And no matter how you delete nodes, add nodes, the tree will be self-balanced. Now let's go for the actual definition for tree map class. So tree map, you see here, map is being extended by sorted map, navigable map is extended by sorted map, and tree map, what is the relationship here? Implements this particular map called navigable map. Now TreeMap class in Java is a concrete implementation of the sorted map interface, which means that it maintains a sorted order of its keys. Tree maps are implemented using a red-black tree, which is a type of self-balancing binary search tree. So this makes tree maps very efficient for lookup and update operations. See, self-balancing binary search trees, one of the main uses is it's used in database management systems to maintain indexes so that search of your database queries is efficient. The tree is always balanced. So that's one of the uses. So now let's go to tree map demo. How do you create a tree map? How you call all the various methods of tree map? Let's take a look at the demo now. Let me go to Eclipse and start uh, giving the demo. Let's go to Eclipse. Say you want to create a tree map. How is that you create? Please maintain silence. If you want to take the class, you are welcome. I don't want anybody to override my voice here. Okay, so we'll take a look at this tree map demo. So how do you create a tree map? For that you give an object tree map. See, this is the question he asked. When I create a tree map, what will be the type for the keys? Data type for the keys, say here I give the data type to be integer, or it can be string, whatever it is. I give it as an integer and the value is a string. That's how you create this obj, or I can call this like some issue in my laptop. I can call this Java class is equal to, then you create this new tree map, like how you create an object, that's it. And again you mention whether it is integer comma string. Your tree map is created. Now if you want to insert some values, key value pairs, how will you insert this is you use the object name. You use the object name Java class dot, and then you call this method put, and now you pass the integer key. Say integer key is 1, the value is a string, so you can pass the name. Just give my name here, okay? So like that you can insert any number of key values, but you have to understand that key is unique, values can be duplicated. So I can just replicate this. I'll add more key values here, say 2, 3, 4. Names can be duplicates, not a problem. So Ram, we'll have Chris, we'll have Jeff. Just to check whether this is sorted or not, when we create a tree map, let's insert like this 4, 2, 1, 3. We are not inserting that in the sorted order. So we have inserted this. Now we can take a look at some of the methods. The first method is we'll just use first key. Sys out. I just want the first key from this. So Java class is the object name dot first key. What is the use of first key here? What will be the output?
One.
1 or 4 or what is that? So let's take a look at this output. 1. See, what is happening here is it's automatically sorting because tree map inherits sorted map too. So what is happening is the key value pairs are sorted in the ascending order. The first key is 1. Now what will be the last key? There's another method called last key. So last key will be 4 here. So let's execute this. Last key is 4. Likewise, you also have other methods, first entry and last entry. Let's execute what is first entry. What will be first entry? The first key value pair. So first entry is nothing but the first key value pair. See, 1 Chris is the first key value pair according to the sorted order of the keys. Likewise, you have another method, last entry. See, internally, a red flag tree is maintained for your keys, and then every search and all the operations is being performed on this self-balancing binary search tree. That's the meaning here. So let's ask for the last entry, and it's all sorted too. Let's execute this. So you're getting this last entry as 4 and Satish. Got it. Are you clear with these methods? Put for inserting, and first key, last key for getting the keys in the sorted order, and the first entry and last entry is for getting the first entry and the last entry. So now we'll try the next method, that is we'll try this method get object get. We'll try this next method get method. What is the use of this get method? Let's perform this. So we'll use the object name of the tree map java class dot get and then you should pass the key. Here I'll pass the key as 1. What will be the output here? Chris. So you're using the key to get a specific value from the tree map. That is the search. There's one more method, contains. What is the use of contains? We have used that with string handling. We have used that with other concepts too. So we can check whether it contains a specific key, whether the tree map contains a specific key. So we use the tree map object dot contains key is the method. We pass the key. So it's a Boolean method. It will return either true or false. So here we have this key. So what will be the output here? The key is present, something like that. I'm just giving it. So what will be the output here? The key is present. If the key is not present, it will return a false. So this method contains key is used for searching a specific key, like whether the key is present or not. It's a Boolean method. You want to search for a value, it just dot contains value. Contains value. Now you have to give the value. Let me search my name Satish from this map. So you're going to say the value is present. You execute this, you can see the value is present. Are you all clear with the methods of the tree map? Now we'll go further. We'll take a look at this method called entry set. We'll take a look at this method that's called entry set method. What is the use of entry set method? It returns all the key value pairs to you. Say, I'll just perform sysout java class dot entry set. Entry set will return all the key value pairs to you in the sorted order, obviously, because of sorted map there. So 1 Chris, 2 Ram, 3 Jeff, and 4 Satish. So that is the use of entry set. Okay. Now, if I give you a question like count the number of students whose name starts with an S in your tree map. Count the number of students whose name starts with an S in your tree map. Now the challenge is we have to access every key value pair independently, and then you have to go to the value, check whether that particular value starts with S. So how to traverse and access every key value pair independently is the next question. For traversing, we are going to use a simple enhanced for loop. And you have to understand the entry set method returns all the entries. From the entry set, we are going to get every map entry. So let's take a look at this. Let's go with this for loop. So we are going to get every map entry. So it's map dot entry. What kind of entries we are going to get, that we can mention. So we can just give map dot entry, not a problem. Map dot entry. So we'll get every let's say key value pair, something like that, key pair from Java class, the TreeMap dot entry set. So what's happening here is this entry set returns all the key value pairs as a set. From this is one map entry. This is another map entry. So what is the meaning here? This map entry contains a key and a value. So you're retrieving every map entry from this entry set, and we can just sys out say key pair dot get key. So what is returning with respect to key pair? A map entry. So you'll have a key and a value. So I'll use that key pair dot get key to show the key, and if I want the value, I can use key pair dot get value. Now let me run this. You will see this is the keyPair.getKey, value. So this is one map entry. So you are getting all the entries. From that we are retrieving every map entry. A map entry will contain a key and a value pair. So this is one map entry. From this map entry, what I call this map entry as key pair. So key pair dot get key will return this. Key pair dot get value will return this. So that's how you traverse. Now you have this get value, right? You'll be able to say key pair dot get value dot starts with yes, count plus plus. Simple. Are you clear with this? Let's take a look at this method called key set method. What is the use of key set method? There's one more method called key set which we have seen. So it's Java class, the TreeMap object dot key set. Let's execute this. Let's take a look at the output. 1, 2, 3, 4. So it's just going to return your keys in the ascending order. Entry set will return the key value pairs in the ascending order, whereas key set will return only the keys in the ascending order. There's also one more method called descending map, which is from the navigable map interface. So we'll see what is the use of descending map. So descending map, if I call descending map and throw the output, you're going to see it reverses. Now, normally the sorting is in the ascending order. Descending map will show the output in the descending order. So it starts with the highest key 4, 3, 2, 1. So navigable map is used for traversing a maps in both the orders. And there are a few more methods like higher key, lower key, floor key, ceiling key. Lot of methods are there. We're just looking at a few more methods and then we'll wind up TreeMaps. That is Java class dot higher key, and I enter a key like 3. It'll return the immediate higher key to 3. What is the immediate higher key to 3? It'll return that as 4. Likewise, you have lower key, that is dot lower key you can give. What is the use of lower key is, it will return the immediate lower key to 3. What is the immediate lower key to 3 is 2. Let's execute this. So like that you have various other methods like ceiling key, floor key, all those things. Let's not worry about these things. We also have other methods in TreeMap. Let's take a look at a few more methods. This is very simple. This is out Java class. Java class, that is the object name dot size. It returns the number of elements, key value pairs in your map. And also sys out. You can go with removing an object, that is Java class dot remove, and then you have to pass the key which you are going to remove. Say let me remove key, that's 2. And if I want to traverse and print the remaining entries, I will print for map dot entry, and this we can remove. We can give some the key value pass we are getting, we call that as ELE. From, we'll say that is Java class dot entry set, and what we'll do is here we'll just print this out. We'll just print the keys here, element dot get key. So you see here,
Giving the value back whenever it's doing the addition.
it's also removing it, and then what it's performing, it's just telling you the remaining keys. So you can, yeah. See here, no need to actually print. If you are removing, you can just like that directly remove. What is that we are going to print here? It's not needed. It's returning the value. But this solves it. from this demonstration, what is that you understand this? What is a tree map? And how is this tree map implemented? What are the interfaces a tree map inherits? What are the interfaces a tree map inherits?
Map,
Map?
sorted map, navigable map.
Okay,
But wait,
that's good. So, and you should know these methods: put first key, first entry, last entry, contains key, contains value, entry set, map entry, traversing an entire tree map, and you have to get the keys and values for every map entry, and also key set method, descending map. We have seen higher key and lower key methods.